There we go. Yeah, so if you came in, there's 12-4 assignment. As always, you just do as much as you can to get ready for the test, which is tomorrow. So. So guys, let me say, here's a general idea about what we're going to get into. Remind me, what are logs fundamentally? What's the answer to a logarithm always? A power. They are powers. So the properties of logarithms are going to be the exact same as the properties of powers. Namely, if I had like b to the a times b to the m, what do you do with the powers in that case? So if I just look at the powers, if I just look at a and m, what am I going to do with them? Add them. So this will become b to the a plus m, right? Is that cool? Are you guys okay with that? Can you guys get past the a and the m? Doesn't matter what number I plug up there. What am I always going to do? I'm going to add them together. Now watch. What does this look like in logarithmic form? Guys. So this can be represented log base b of something. And this would be times something else. So this is going to be b to the a, b to the m. This is like x, this is like y, x, y. So what the log says is focus on the powers of these things. B to the what is x, b to the what is y. Well, b to the a is x and b to the m is y. We don't have to know all that. What would I do with the powers when I'm multiplying things with like bases? I add the power. So what's the power on the b to make x? Log base b of x. And I'm going to add that to log base b of y. So we tie these together. So logarithms focus on the powers. They say, what is the power? What's happening with the powers? So when I'm multiplying two things with like bases, do you guys see how these both have base b? Because they're in a log base b question, right? What do I do with the powers on each? The power on that one is log base x. Power on that one is log base b. Why? I add them together. So if x is b to the a, and y is b to the m. Right. I'm sure you guys, this is the explanation behind what works. It's not what you have to be able to do every time. This is why what we do works. Okay, I always get somebody like, am I supposed to be able to do that? I should know. So what would this look like? This would look like log base b of b to the a times b to the m. And supposedly that equals log base b of b to the a plus log base b of b to the m. Now what is log base b of b to the a? We just had one like that. A. What's log base b of b to the m? M. And look here, what do I do with the stuff on the inside? What do I do? So what's log base b of b to this? That. So a plus m equals a plus m. So the very first property of logarithms is this one. It says, if you have the log of a product, what do I do with the powers when I multiply things with like bases? I add the powers. So the log of a product is the sum of the logs. That's the exact same property as the property of exponents. What use is that shit? Well, let me show you. Can you tell me what log base 6 of 3 is? No, let me just save your brain. You can't. You can estimate it. You can kind of get close to it. You can tell your calculator to do it, and it's not going to tell you the right answer. It's going to give you an approximation. But if I add that to log base 6 of 2, do I know what either one of these stupid things is? What do I raise 6 to get 3? I don't know. What do I raise 6 to get 2? Look at my first answer. I don't know. Well, what am I able to do with these things now? No. When I have two powers adding, what was I doing? I must have been multiplying. If somebody added the powers, what must have been happening? I must have been multiplying. So I can write this as a single log. Log base 6 of 3 times 2. What am I doing with, what's log base 6 of 3 represent? What does it represent? The power on 6 to make 3. What's log base 6 of 2 represent? The power on 6 to make 2. So if I'm adding them, what must I have been doing with the two things? I must have been multiplying the two things. So I can take the sum of two logs and make it the log of the product, because that's what powers do. That's how they work. If I add two powers, I must add a problem that had like bases multiplying. That's when you add powers. So I see adding powers. I make it the log of the product. I must have been multiplying. And this is log base 6 of 6, which is 1, which I can now do. So that is one way that that's useful. It should feel a little bit like square roots, to be honest. Again, remember, logs are very much like square roots. So if I had, or cube roots for that. If I had cube root of 4, do you know what that is? No. But if I multiply by cube root of 2, you don't know what that is either, but I can write this as cube root of 8, which you can now do. So I had two parts, neither of which I know what to do with, but I'm allowed roots work this way, and I get something I can actually do. Here, I have two things I don't know. Logs work this way, and then I can do the result. So that's one way that this property is useful. Yes?
If you were to put that in the calculator, log 6, 3.
Yes, you would. If you put log base 6 of 3 and you put log base 6 of 2, and you added them, you will get 1.
Okay.
That's what this is saying. Cube root of 4, I don't have a clue what that is. Cube root of 2, I have no idea what it is. If you did that in the calculator multiplied, you get 2. Same way. Okay. Remember. So if log base b of x plus log base b of y is log base b of xy, right? What do you think log base b of x minus log base b of y is going to be? Why is it this? Because when I multiply things with like bases, I add the powers. When do I subtract the powers? What must have been happening?
Division.
Division. Okay, cool. I like it. How are we doing so far? So those are the first two properties. There's one other one. The next one is based on the first one. So if I have, let's see, if I have log base b of x to the m, we're going to do some concrete examples. We're just studying the idea. How can I rewrite it so I can use the first property that says I can rewrite a multiplication as this? Well, what is x to the m? What does that mean? Don't say x raised to the nth power. What does it mean? It means m what's doing what? What does x to the m mean? How do you figure out 7 to the 8th power? If I said do it on your paper right now, what would you start doing? 7 to the 8th power. 7 times 7 times 7, 8 times. So what does x to the m mean? X times x times x, m times. So this would be log base b of x times x times x times x times x, m times. Don't freak out because it's an m. If an m was 7, there would be 7 x's. That's all I'd say. Whatever m is, that's how many there would be. Of course it is, right? We know how exponents work. But now do you see how I can use this property over and over and over and over? This would be log base b of x plus log base b of x plus log base b of x. See how this says if I have a product, I can rewrite it as a sum. So I have a lot of products, I can rewrite them as a sum. How many of these log base b of x's am I going to have? M of them, of course, because that's how many of those I had to break up. So if I had like 7 8s that I had to add, what's the quicker way to do that?
7.
7? What was that? What if I had... That was so neat. If I
I was hoping
sorry.
someone would finish my
I love it, man. 7? No, shit. If I had, what did I say? If I had 8 7s, or what did I say? 7 8s. If I had 7 8s, 8 plus 8 plus 8, 7 times. What's the quicker way to do that? I just basically gave you the answer. 7 times 8. That's multiplication, right? So I have m of these that I have to add. So what's the quick way to do that? I just say m times this. This is still a property of powers. Look at this. What's log base b of x represent? What does log represent?
power.
A power. And it's being raised to another power. What do you do with two powers when you're raising one to another one? What do you do with these? Multiply them. So what I do with that m power and that log base b of x power, I multiply them. Because that's the property of powers.
So you do the log first and you multiply?
If you had concrete numbers in here, you would do this piece and then you can multiply by m. Sure.
Yes.
I like it. This is the most important one up here, to be honest. We'll eventually see how this helps me solve equations. But for right now, let's do some concrete examples. So if I had log base 5 of, what you got, Jeff? 60 minus log base 5 of 12. I have no clue what either one of those is. And I know somebody out there is like, that's right. But yeah, you don't. You shouldn't. What's square root of 87? You don't freaking know, neither do I. Right? So these, I don't have a clue what either one is, but how can I rewrite it and hope that the rewriting makes it something I can do?
Put it in exponential.
Log base 5. We can't put in exponentials. 2 logs and they don't equal shit. Log base 5.
60 divided by 5.
Yeah, I'm subtracting powers, so what must have been happening with these? They must have been dividing. That's when I would subtract powers, when I'm dividing. If you know properties of powers, you know properties of logs, period. And what is 60 divided by 12?
5,
And what's log base 5 of 5?
1.
There you go, sweet. So you reorganize the problem into something you can actually do.
So when it's subtracting, you're dividing. When it's adding, you're multiplying.
Be really careful that you don't do this. Erase the board? No. That you don't do log base b of x minus y equals log base b of x over log base b of y. Don't, if you're writing it down, do this, do this, do this. No. Don't do that. Hell no. That's not the way it works. That's backwards, right? If I had log base b of a division, then I can write that as log base b of x minus log base b of y. That's the rule. That's how the rule works. I subtract powers when I was dividing the things. Yes?
So if you had log base 5, 12 minus log base 5 of 60 is 12 over 60?
Yes. And then it would have been 1/5, and it would have been negative 1.
Okay.
You guess. So you can't choose which way to do this. Why did I put 60 on top? Because it was the positive part. If this was turned around, so he's got a good question. If this was written the other way around, log base 5 of 12 minus log base 5 of 60, that would have been log base 5 of 12 over 60. You don't get to pick because you're like, I don't like that one. You didn't turn it around. No, you don't get to pick. This would be log base 5 of 1/5, which in this case would be negative 1. Sweet. This makes sense. Bigger minus smaller comes out positive. Smaller minus bigger comes out negative. That seems to make sense. Okay. Okay, yes.
Another question, will you ever have, on this test, would you have a concrete answer, or is it gonna be like blah, 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 blah?
No, there'll be some like concrete answers, and there definitely will be some with just variable stuff in it.
Okay.
Here's one. See what you can do with this. Nothing changes. You just have a little extra right inside. Still, the process doesn't care. The property is the same.
Okay, I see.
When you think about a printer, got into some good drink or something, you know, drunk,
Good.
a little off thing on the bottom. I got you, buddy. I got you. Sorry. It's completely exactly the same as the one sitting right next. Log base 5 is something minus log base 5 is something. I write that as log base 5 of the division of those two things. Just because I wrote x squared minus x instead of 12 or something doesn't change the first step. No. Not because I say so. 'Cause that's how math works. Yeah.
So, can I do this? I don't know.
It's the law.
Of course.
Okay.
See how that's exactly the same thing we did. What did we do right there when I wrote 12 over 60? We canceled what was common.
Yes.
So why would it happen any differently?
Okay.
For x's. X's are numbers too. I want to get a shirt that says.
That's what it is.
Exactly. All variables matter.
Log 7x because you GCF.
All right. Really, I mean, this is huge. This is what I keep trying to get you guys to realize. Once we develop a property of math, it doesn't matter what's in there. The property just says the same thing happens. So if I have log base 7 of something minus log base 7 of something else, I can write that as log base 7 of that thing divided by that thing. Now I'm worried about the next step, because that was easy. I just had to reduce numbers. Yay! Here, it's just as freaking easy. I just got to reduce this. You know already you don't kill the x. You know better than that shit. What do you do at the top? Factor it. Yeah, GCF. And then kill. So the answer is log base 7 of x.
No, I'm not next that question.
Okay.
Next one.
So everything I did here was exactly the same thing I did here. Exactly. We just are not, we don't have to rewrite this as 12 over 12 times 5 and then cancel the 12s, because we know it's one, Here I have to write it because it's variables, but it's the same steps. All right, I just gave you this. So you can see at the bottom, I don't have a clue why it decided to be all off-center. It's okay on the back. But I want you to try, I've got each of the properties. The first one's outside the box, but oh well. It escaped a bit. And on the back is the other properties we just talked about. Go ahead and try to do those problems. And then we'll do them together.
Yeah.
Like crazy ass Jeff does all the time. You guys can work together if you want to. If you don't have a clue what to do, try something. It's better to make a mistake than it is to do nothing.